Well, thanks all of you for calling in this webinar, and it's great to talk to all you guys. And so what I'm going to do this time for this report, I'm going to start backwards, and I'm going to start answering the question, not at the end. I'm just going to start answering at the beginning. So I'll give away the final notes, and the reason is because this is going to set the stage for the discussion. And as you will see, some of the topics I will cover very briefly because I am lucky enough to have great speakers that will do some of the job for me. But I will try to present a sort of high-level view, and then they will go into more details along different directions. So clearly today there is a lot of expectation, anticipation, and I would also say hype and a lot of fear. So there's a lot of there's a lot of interest and in both AI, machine learning, and automation as well. So the question is, why is it now? And I think that this is an important question to answer because it sort of explains where are we and what are the opportunities. So in the past, there has been a lot of work that has been done on both artificial intelligence and machine learning through the past decades. So there is a lot of theory, a lot of research that has been done, and there is a lot of expectations, anticipation as to what they can do as tools to improve all sorts of, to improve and optimize all sorts of processes, not just telecoms. However, it was just not really put into use. And specifically in telecoms, in wireless, the issue was that the networks were sufficiently simple that you didn't really need to have too much optimization. You couldn't really optimize too much if something is so simple. When you have just voice and some data, you basically try to push as much traffic as you can, and that's all you do. So the scope for optimization is very limited. And what you can gain also is very limited. So no matter what you optimize, you can improve a little bit performance. And certainly there has been a lot of optimization that has been done. I'm not trying to say that we are not, or we were not trying to optimize the networks, but the gain was limited because you were constrained by what the equipment could do. So you try to get the best out of your equipment. And the computational power was also limited to run all the training and all the AI and machine learning systems. You know, Tero can tell you more about that. It used to be that you knew how to do it, but you didn't have the power to do it. You'd have to, you know, to run time on a supercomputer. Things would take forever. You know, you go overnight, over the weekend. So that was just very limiting. Right now, you can, the processing is so much faster and cheaper that you can try all sorts of new things, and you can run things in a very short time. So the opportunity now is in the network diversity and transformation. So the networks are becoming much more diverse, and therefore they're also complex. There is more applications, more use cases, both for humans and IoT, and that gives us the much more complexity, but also the ability, we also are able to access much more data that is created by this kind of environment. And this has really been important in terms of creating the complexity that we need to optimize. Now, where is the complexity coming from? And so it comes from multiple levels. It comes from devices. It comes from the applications. This goes from URLC, which is basically very low latency applications, to best efforts data, which is, you know, things like text or browsing. And the use cases go from IoT to voice, traditional voice. Access technologies, there are many technologies that coexist. At the RAN, this includes Wi-Fi. At the RAN, you also have massive MIMO beamforming. There you just have huge amounts of complexity you have to deal with. You know, for massive MIMO, we have thousands of different configurations. How do you pick the best one? Humans are not really good at that job. We understand the high level theory, but we are very bad at turning the knobs. Edge computing, cloud, and virtualization, and Caroline will talk more about it, also increase the complexity of the network slicing, the need to manage traffic at the application level, the need and desire of operators to use policy to manage their resources, and then monitoring and optimization in real-time analytics also give you an additional layer of opportunity. Now, what that does, if you think about it in a sort of big picture, you have so many more variables that can change that an operator can set at different times and in different places, because you're not going to set this for the whole network. You're going to do it at the specific place at the specific time, and you have all of those variables. Now, what is even more challenging is the fact that all these variables interact with each other. So the way you manage your run depends on what applications you have or what policy. So it becomes really complicated. And if you think that humans, we're very limited in that way. Our short-term memory is less than 10 elements. And here, as I said, just for massive MIMO, you have 1,000 different configurations you can go to. So clearly, we are not able to keep up with this. But we have to think about that complexity as an opportunity. It's a challenge that we have to face, but once we go through it, it's an opportunity because we can improve performance through optimization. So what we can improve, here are some areas: the quality of experience, reliability, utilization of network resources. You can basically get more out of your network, increase the throughput, capacity density, which is basically how much throughput per a single location. The latency where needed, and what that means is that you just want to have lower latency for some applications, not necessarily for others. So you don't necessarily want to lower latency for everything, but only where you need it. So and that's where it's tricky because it becomes more complex. You can lower the cost for valuable bits. What I mean here is that not all bits have the same value, so not all traffic has the same value. So it's important to lower the cost for the traffic that it's most valuable to you. And then you can support new use services and use cases. However, in order to do this, in order to improve that performance, we have to go a little bit of a step forward, further. And in order to assess and measure the performance and the financial benefits, we need to have a new model. So not only we need to do things differently, we also have to assess them in a different way. And it's more in the long term, because initially learning, as you know, when if you watch kids learn, takes some effort, takes some time. So you don't have the 1 month return. It takes time to get to the point where you're actually learning. It's an incremental process. It's a continuous process. You don't stop learning. You continue to learn. You continue to improve. And it's an end-to-end. And I'm going to get to that, back to that later. It's not just something you put here and there. It's something that goes deeply in your organization. And we have to think about monetization in a different way. Instead of getting a few dollars, euros, or whatever currency you have here and there, we need to think about using your resources more efficiently and be more efficient in the revenue generation. So it's a different way to look at it. It's putting costs and revenues together, and not necessarily to maximize or to increase revenues. Now, the other thing it's important that I think is very, very important here is the spillover to the enterprise. The enterprise is also using AI and machine learning, and in many verticals, they're actually ahead of telecoms. And by the ability to optimize the network, we also have the ability to serve the enterprise better, to provide the enterprise a better value. So there is an increasing value of wireless connectivity to the enterprise. And I would say that all of this is particularly crucial when you think about 5G, because you put investment on 5G, and if you are not able to optimize using AI or machine learning your network, it's sort of like having a really fast car and going in a one-street lane. There's just so much you have, and you're basically wasting your money. Now, let me go now and talk. I'm talking here a little bit more at a high level, because here adding intelligence and learning to the network is sort of a deep change. And we need to think about how to approach it so that we don't have our expectations too big and then they cannot be fulfilled. So one thing is that, should we talk about artificial intelligence and machine learning? And to some extent, it's a terminology issue. There is a lot of different people mean different things, but I think it's more than semantics. And what we should think about is, intelligence is a highly charged word, and we have human and artificial intelligence. And when we talk about AI, I think we need to think about intelligence in terms of being able to understand and optimize our networks, but not to see it in contraposition or in as a sort of in competition with human intelligence. They're very different, and they serve very different purposes. And what we need to, the reason why we need artificial intelligence is not as a substitute, but on the opposite, to do the things that we are not good at. Humans are wonderful machines. We're very good at insight. We're good at figuring out things, but we're very bad at boring tasks that require a lot of data and looking at different things at the same time. Machines are much better than us at that. So when we think about artificial intelligence, we should sort of not think too much about human intelligence, but think about a different type of tools and learning. And so, so here we have, we need to have we have the learning, we have the intelligence part, and then we need the automation. And this is really what makes it happen. Without automation, it's like having a bunch of humans trying to solve a problem. It's just like, yeah, eventually you can get something done, but it's not really quite as powerful. However, and said that, there is a lot of hard work ahead of us, and I'll get to that later. One thing that we need also to look at is the culture and expectations. I think that this is really important. There is often a tendency to look at AI as a black box. You don't know what's going on, or as a magic box where you put something in and you solve all the problems of humankind or neural networks. And I think that it's neither of them. It's clearly we need to get used to a non-deterministic environments where we cannot control everything. So we need to sort of let go, and the way we have to get there is by getting more and more comfortable by trying, and learning is a continuous process, and it doesn't always go up. Sometimes you learn, and as you learn, you step back a little bit. So we need to be accepting that, and humans are part of this process. We have to learn too. As our AI systems are learning, we need to learn too, that we have to deal with this in a different way. And that also brings a lot of cultural change. Now, AI will not take over humans, but will change the way we do a lot of things. It will be a relief, but also we need to deal with it from an organizational point of view. We need to make sure that our structure, the organizational structures, the assessment of human performance and the skills are go in line, evolve with AI and machine learning. Now, and so here it's sort of like again, looking at this, we should think about AI and machine learning as end-to-end tools. And here in the graph, you see all the, you start collecting the data, and it's important to have a good data to start, learn, understand, identify, and then eventually recommend, predict, and enact change. Now, at the beginning, you might just have the first steps to be offline, so you gain the confidence, and then you can do everything online. And this, however, as you do that, you need to ask yourself, what is that you're trying to optimize? This is really crucial. Optimization is not a one-way street. You can decide, for instance, you can optimize a network for latency or for throughput or for quality of experience. You have to decide, and if you want to optimize for different things, you have to give it different weights. So it's not just, is it optimized or not, it's how you optimize it. And here, I just put the use cases. I'm not going to go through them. I just wanted to show you that there is so many of them. What does that mean? Is that AI and machine learning only work if they are they penetrate and they go down in the way we run and plan for our networks. So it's you don't want to have a use case based type of application application of AI and machine learning, but you need to have it sort of pervasive. It has to go end to end so that it then can serve all these use cases automatically. Now, I do not want to spend too much time because I want to make sure that the panelists have time. So here are my sort of closing points. And again, there's a lot of hard work to do. But the rewards are also big. Not only the rewards are big, but it's really, you have to go through this because you need it as we move to 5G. It's necessary to get our networks to be smarter and to be able to learn continuously. So this is all from me, and I would like to move and have Caroline Chen, who is the VP and General Management at the Network Business Incubator at the Data Center Group at Intel, to tell us a little bit about her, and then I'll have some questions. Caroline, to you.
Hi, everyone. I hope you can hear me good. And welcome to that you join us in this. I think it's a very important topic. I'm sure we'll be talking more and more about this, because as we were embarking on this 5G journey and the network transformation journey, what the end result is that you really are seeing a convergence of the cloud and analytics onto the network. So Monica did a really good job in outlining why AI and machine learning have become ever more important. And my fellow two panelists that's going to deep dive into it. I just wanted to take the opportunity to give everyone a view of how we, with Inside Intel, how we think about this as we are building, we are the technology partner in this journey together. So for the past few years, we've been embarking on this network transformation journey. What we are seeing is that once the networks start getting more cloud-like, in fact, we hope that in Mobile Congress, there'll be more and more, we'll be announcing, participating in several announcements and showing that a cloud-native network does work and can deliver the performance and the price target that the industry are expecting. Once we did that, what the advantage is that you have this proliferation of intelligence permeating throughout the network. And by that, what we really meant is that if you're looking at the cloud, what used to be run in the cloud, the data, the analytics, the AI, and the inference started to pushing towards the edge of the network. And just like Monica was talking about, what it really does is that it gives the operator many different ways to fine-tune the network for different verticals. Because for 5G to be truly successful, or for any future network to have a thriving return of investment, we won't be able to just focusing on one type of network or one common network for all. It really is a one common physical network, but tuned for different slides for different verticals. So in the report that we share, we work together with our partners, with Monica, we talked about some of the use cases that really start driving the need for a cloud native, the need for AI and data analytics, not just running in the cloud, but also running at the edge. What the picture here is actually what we're using as a North Star inside Intel to how to drive our future platform. Our envision is that if the 5G network will really looks like a cloud data center that happen to run a 3GPP compliant protocol. But in addition, every node in the network could become a MAC node or edge compute node. Every node is capable of running the AI and data analytics that we all want to see. I specifically want to talk about the one of the concepts that is in the report is that how does the enterprise uses the network? What we're seeing, what the unified network really needed to serve IoT. When you dig into the IoT, you start seeing a very different verticals have different needs. Telemedicine, factories, sports, cloud gaming, or even just supply chain optimization, all have different requirements that imposes on the network. In the interview that I had with Monica, I was talking about my first job out of college was with a major telco manufacturer. One of my job was actually to monitor one of our largest customers' network usage. We have all of their NOx data coming through. And think about, so I'm probably dating myself back then for a new college grad, what they put you in front and start looking at all the alarms and coming in and use some judgment call to decide when we start needed to provisioning some of the additional channel element cards that need to be getting into the warehouse and ready to be shipped out. A lot of it is very subjective. The amount of intelligence really relying on what we learn in school and what we get trained and some of the best known methods passing down from previous the more seasoned engineers. But that kind of skill set will not be sufficient when we looked at a multi-dimensional network that we will be facing tomorrow. Just looking at the proliferation of intelligent devices in our home, in our industry, we currently working with several large industrialists in US as well as outside in Europe. We're working with the Chinese cloud service provider to start provisioning an intelligent highway. We work with the retail firms. How can we treat this as one single network physically, but yet to be able to provide all the services we wanted to deliver at the most cost-efficient way? That's why inside Intel, we keep looking at the network, not just as a network of yesterday, but really a convergence of the cloud, the media, and the and AI and blockchain really becomes the application that has to be run on this network to enable a profitable, a multi-dimensional 5G network. So I just wanted to take this opportunity to lay out some of the foundation of what this 5G network can provide, and we'll have a robust discussion, especially I know my two panelists will be talking deep dive into machine learning and AI. How does that help fine tune the network? Monica?
Yeah, so Caroline, before we get to Tero, what is it you're hearing from operators? Because there is a huge opportunity clearly, but are they ready? What steps are they taking? What is it you hear there?
What we're hearing is that there's a strong desire to drive towards that. Well, we used to start talking, I just remember I used to go to 4G Americas and now 5G Americas. The topic has always been, do we need a virtualized network? Now, last year, the topic has become, now that we have virtualized network, how do we get AI and machine learning onto the network? there is a concern is that can the network operators infrastructure keep up with the demand, keep up with the complexity of the application that inevitably drives the demand onto the network. I think we are at the starting point that everybody recognizes that we need to get there. It is very important that we set the right technology path, we set the right target, and to get us there. So we are probably at the beginning of the hockey stick in terms of AI and analytics running on the network.
Yes, and so what is that you're doing at Intel? You mentioned, meetings and talking to the different enterprises, operators, because if it's a deep change, the ecosystem has to change as well.
That you're absolutely correct. Since we are now somewhat not a pure telco industry, the telco itself really becomes more of a telco plus IT. So we actually wind up spending a lot of time talking with the CIOs and the IT folks. And they have, in a way, relying on the cloud to run some of the AI analytics. And there's a strong dependency on that side. What we're saying is that, look, with the network becoming cloud-like, cloud native, we had the opportunity together to move some of that from the cloud to the edge. The reason is that because of latency, the reason is a lot of it is a localized intelligence that needs to be utilized at the spot. Because many times if it happens at factory, it retains in the factory. So the ecosystem is really beyond what we traditionally talk about on the telco side. We wind up working with a lot of IT folks. We're actually pushing out proof of concept. We're pushing out SDKs, the software development kit, to really establish a new, more of a hybrid ecosystem that complement what we always have, which is the telco-centric one.
Yeah, absolutely. Now, you talked about 5G, but 5G is not here yet, by and large. How do you see AI and machine learning being affected by 5G? Do we need to wait for it, or can we go and get started already?
The work has started. So 5G will be here in large deployment in a couple of years. We're seeing the trend very much supporting that. But the work that is already starting, we're already working with our ecosystem running on LTE. We already have network slicing pushing out. I mentioned that we have proof of concept already working on a blockchain and AI running on a 4G network, a virtualized 4G network. Especially around the ecosystem seeding, that type of momentum has been built now before 5G really comes in large scale deployment. I will argue even that if we wait for 5G to be here, it's too late. That network complexity can very well diminish the deployment speed of 5G and will actually hurt all of us in this industry.
Absolutely. Okay, Caroline, thank you. And we're going to get back to you for the Q&A, but let's move to our next speaker now. Hold on here. How is it that I'm not able to go to the next page? Sorry about that. There. Teresa, Chief Architect in Machine Learning, Nokia Mobile Networks. Tero, thanks for being with us today.
Thank you. Very good to be here.
Okay, Tero, why don't you tell us a little bit about yourself, and then I'll have some questions for you.
Yeah, so I've been leading the machine learning activities here in Nokia Mobile Networks for a year. And as I think a lot of the key points have already been presented. So we are introducing 5G in the market, and the complexity of the overall system is overwhelming to a human being. So if you go to the next slide, the main topics we have in our vision for AI-powered networks is what has been presented. So we have complexity in the coming 5G that is beyond human capabilities, in that we have tens of millions of different combinations of parameters in a one optimization task alone. But also we have to support the previous generations. And on the other hand, the economics of our industry is such that all the savings and the biggest profit can be made by optimizing and automating the net operations of the network. So these are kind of the drivers that pushes us to use machine learning heavily in the networks. But on the other hand, we have also the opportunity of utilizing machine learning as a tool to optimize the network into the specific operational environment. So take into account the people and other machines, the infrastructure, the buildings and the natural terrain in all the communications that happens around each element of the network. So it is at the same time something we have to do, but also something we can greatly benefit. And in the next slide, I'll just briefly touch points on the different kind of broad areas that how we see we can go towards the vision of the AI-powered networks. So this is partly here to show that how we can go beyond the hype. What are the actual tangible tasks we can do, and where we spend most of our time when we're actually doing real work with machine learning. And the most important thing is the expertise development. So currently there is a huge demand for machine learning specialists, data scientists, and so forth. And there's no way we can satisfy the requirements by hiring externally. And also, what this transformation means is that everyone will have to have some level of machine learning understanding in the workplace going further. So this is part of the cultural change you mentioned earlier. So we really put in a lot of effort to train our company and having a systematic and organized way of educating everyone to certain degree of machine learning competences, and then going as deep as is needed to gain the expertise. We have machine learning leads nominated for each tribe we have, and we then also provide the infrastructure and the tooling for any group to start using machine learning as easily as possible. So basically, design for machine learning from this year, or actually last year, 2018, to the future. Then what we're focusing also is the AI ML algorithms, and then using of AI ML in a traditional algorithms. So these have been mentioned several times. So radio resource management optimization and massive MIMO scheduling and these kind of things that are basically like breaking the ice towards fully enabled networks for machine learning, meaning that we try to make small wins, small meaningful wins where machine learning is used in a way that it is beneficial. It will not change the world in one go, but we can show them and implement a machine learning in a working deployed environment where it's better than what we have previously used. And with a small gradual increment, we can then start first start walking and then start running. And in here, maybe this predictive time series machine learning algorithms is worth mentioning that it's something we have to invest a lot of ourselves. So we're not doing traditional image and vision natural language processing type of algorithms, and a lot of our network problems or application areas look like a time series problems. And unfortunately, there's not that much focus in the academia there as the other areas, and that's where we're putting our bets at the moment. Then the hardware acceleration. We recognize clearly that a machine learning as part of the infrastructure, so closed loop inference, requires a acceleration for machine learning. And we really going forward with this with the strategic technology partnership with the leading solutions. And then mentioned already as before that this has to be done in partnerships with operators. So, for example, we have publicly announced the Memorandum of Understanding with China Mobile, and then we have similar collaboration going on with other operators. And basically, jointly to collaborate to introduce these first meaningful machine learning applications to the operations of the networks. So that's basically why and how we are going to approach machine learning in our vision going forward.
Okay, Tero, that's great. I know that you've been working on AI and machine learning for quite some time. So I wanted to ask you, what is changing, and what has changed over, say, the last 10 years or so?
Yes, so 10 years ago, actually, it's about the time when I last stopped doing machine learning for a while, and I gave up because I didn't see progress there going forward. Basically, just in the wrong time when something started to happen, and now I'm back at it. So I think three main things have really transformed the machine learning landscape. And first is algorithms. And some of these algorithm changes are really simple, like recurrent linear unit ReLU as a activation function has enabled, although being really simple, a much deeper networks. And then just stochastic gradient descent application of it, and the general understanding how to apply supervised learning. There's vast amount of new experience there. And then if you want to wander further, then there's endless amount of new techniques that can be examined. So if you want to go to reinforcement learning or use GANs, for example, there is so much you can then leverage in the research wise from the previous. But the second thing is just a increase in productivity in form of frameworks. So Keras and TensorFlow, PyTorch just directly impacted that. And then there are these kind of auxiliary things like Docker, Kubernetes, and then acceleration libraries from multiple vendors providing acceleration hardware, which then brings me to the third thing is the hardware, the computing capacity. We now casually talk about hundreds of teraops of capacity with multiple teraops per watt energy efficiency. And it is just mind-boggling to think that 10 years ago we were talking still few gigaops per second performance. And we're now seeing the advance of reduced bit width, so fully machine learning optimized architectures. We still have architectures that are designed for some other purposes, but they're good in matrix multiplication, so they are very good in machine learning inference as well. But now we actually start seeing the emergence of highly efficient custom-built machine learning architectures that still are matrix multiplication, but for example use reduced bit width on integers and so forth. So I think these three things have really changed in the past 10 years.
Now let me ask you the other question, the other side. What's going to happen over the next 10 years? You mentioned the fact that it's like at Nokia, it's a big cultural change that affects the whole organization. How should we expect AI machine learning to change the industry?
Oh, that's much harder question. I think actually that there are no longer machine learning jobs. So basically every job is a machine learning job. So you will not have people separately being recruited for machine learning. It's like saying that if you are a applying position for being a director, it doesn't say that you need to know how to use computer. It's kind of assumed. You have to know the basics at least, and every position has to understand what it means. So I think that will change in a way that currently, if you monitor the number of machine learning positions opened in a recruiting site, I think that actually starts to diminish when we get over this phase of really needing the talent too much. I think everyone has to know. Then I think the appreciation of data, especially a data that has labels embedded with insight, that the label gives insight what the data means, what's the correct answer. I think people in 10 years' time will look back and wonder how we didn't appreciate a good training data as much as we appreciate at that point. And I think also that we don't notice the machine learning so much anymore. It is embedded so much into our everyday life. Things just work better, and we wonder how they didn't. But it's not that this is AI or this is machine learning that we kind of assume it's there, and we think that this is the way it's always been. We just didn't notice. And I think 10 years is pretty much the time of actually to the next generation. So maybe 10 years time we are introducing 6G in a similar phase that we are now introducing 5G. But I think that the 6G will be the first generation that is built ground up for machine learning. We are now implementing parts of improving the operations of 5G with a machine learning, but it's not built for it from the ground up. There's still constructs that are made to be human understandable and human controllable. I think for 6G, the big difference is that it's ground up machine learning. I think in 10 years we will advance in general machine intelligence, but actually I don't think we achieve it in the next 10 years.
Yeah. Well, Tero, thank you so much. Again, we'll get back to you during the Q&A. There are some questions for you there. Okay, let's move on to Sachin. Sachin Katti, he's the president and founder at Uhana and the professor at Stanford University. Sachin, please go ahead, and thanks for being with us today.
Thanks, Monica, and thanks everyone. So I think a bunch of things have already been talked about over the webinar already. So let me give some context. From my perspective, I see two big shifts coming in the networking world. So one is, of course, the advent of 5G. But the subtext of that really is the increasing complexity that is going to come within the network. If you take a step back, 5G's main thesis is that it is going to enable a bunch of new verticals. And to enable that, those verticals, the way we have built 5G is to enable a lot more programmability into the network. There are a lot more knobs in the network to program it so that you can customize it for each of these new verticals. And those verticals that we're speaking of, they are becoming a lot more demanding. So we are going from a world where the network was mainly used for consumption to a network that will probably be used mainly for control. And what I mean by that is we will have software running in the cloud, edge clouds, trying to control physical robots like cars, robots, and even in very low latency interactive experiences like VR and AR. So we have this influx of two massive trends. One is the order of magnitude increase in complexity we are seeing in the network, and at the same time, an order of magnitude more demanding applications that are coming on top. And we fundamentally believe that humans will not be able to figure out how to dynamically optimize the network with this level of complexity and this level of connectivity demand. So taking a step back, what we are trying to do at Uhana is trying to build a control plane for the network where we learn the control plane of the network rather than humans design it. So what we're building is a real-time AI platform that will power this network control plane, and it will serve kind of two big objectives. One is towards the network, really trying to automate network operations and optimization. And the other is towards the application to, instead of the network just being a bit pipe, it opens APIs to give applications predictive quality of service connectivity, as well as potentially making recommendations to applications and network slices on how to tune the knobs at the application layer so that they can optimize their quality of experience. All that being said, that doesn't mean that we had to wait for 5G and network slicing to start taking advantage of this. We can actually deploy it in 4G, and that's what we have done at Uhana. And there are a bunch of use cases that are very useful and valuable that can already be enabled by this, both around the network automation as well as on the application side. And I'll give a couple of examples in the subsequent slides. But network optimization, a lot of use cases around just how do you optimize network usage, resource allocation, but really holistically looking at customer experience on a per subscriber level in real time in the network, and being able to optimize the network and tune the network to directly optimize for customer experience rather than for low-level KPIs that we have historically used. On the other side, for applications, we can already start building use cases where we take in real-time telemetry data from the network and expose APIs to applications and give them predictions about what kind of connectivity to expect on a per subscriber basis in real time. And applications can in turn use those predictions to optimize their quality of experience. Going to the next slide. So I'll just give a quick view on the tech stack that we would need to build to enable such a world. At a high level, we like to think of this as 3 big stages: observe, predict, and control. Observe is the first layer that allows you to look at and ask questions at very fine granularity in real time. So you really want to ask questions like what is happening with each device, each flow in the network in real time. And the big challenge here is just the large scale of data that needs to be handled in real time. We are talking about networks, tier 1 networks, requiring us to process on the order of 20 to 40 million events per second, maybe more. And just to put that in context, that is larger than web scale. That is the kind of scale Facebook has to handle in terms of real-time event processing. Assuming you have built that foundation, the next stage is predict, where you're trying to predict network conditions on a per user basis and proactively identify problems in the network before they're about to happen, rather than wait for them to happen and react. And here the big challenge, of course, is how do you train models, how do you train neural networks that can learn to predict very fine-grained KPIs like per user throughput, latency, mobility from noisy data that can often be delayed or lost or could be incomplete. And that's a learning challenge that we have to solve. And finally, it's not enough to predict. It's not enough to observe. You also need to be able to react and control in real time so that you can optimize for whatever is the objective, whether it is that customer's experience or implementing the operator's policy. And this is a hard problem, because control historically has been a bunch of heuristics that human experts have designed. But as the networks and applications grow a lot more complex, it is getting beyond their ability to design these algorithms. So here we are taking the approach of, can we learn the control algorithm? So instead of a human trying to design it, the operator or application just comes to us and specifies what is their objective, what is their policy. And the black box model is given access to a bunch of control knobs. The control knobs could be in the network or in the application. And what we want to do is just train neural networks using deep reinforcement learning that learn how to control these knobs in real time, rather than a human having to figure out how to do it. So that's the end-to-end pipeline. And to really enable kind of this real-time control plane that uses such a pipeline, you need this to be very real-time and scalable. So end-to-end timescales on the order of a couple of 100 milliseconds is what you need to design it to, and potentially going down even further as we get to even more real-time use cases in the future. Just going to the next slide. So these are a couple of examples. These are real deployments in tier 1 networks. So this is deployed as obviously on today's LTE network. So here's an example where we use this pipeline to optimize per user video streaming over the mobile network. So we are ingesting real-time telemetry data from the network, running it through a pipeline, and then the pipeline is for each user who is streaming video in the network. And when I say streaming video, I mean that they are using an application that is using an SDK from Uhana. So there is an ability to influence the application in each device directly. So this pipeline that is taking in telemetry data from the network is learning how to predict per user throughput, and then learning how to recommend what is the right video bitrate to stream at, how much playback buffer to build, and a bunch of other knobs in the application, and is pushing those control recommendations to the software running on each user's device. And this is all happening in real time. And you can see the big benefits you get if you actually give them the application some predictive visibility and control from the network. And the big one I'll point out is rebuffering ratio, stall time reduction. There's almost a complete elimination of stalls if you have such predictive visibility, because essentially you are able to predict when network conditions are about to go bad, when the network is about to get congested, and the player then has sufficient time to react and build up a playback buffer to go through those kinds of poor network conditions. And this does not come at the cost of bitrate, right? So typically when you try to improve rebuffering, you are playing at a lower video bitrate, but instead here you can actually improve the video bitrate and still reduce rebuffering ratio at the same time, all because the application is not blind. It now has predictive visibility and control from the network. Going to the next slide. Here's an example where we are trying to do the network optimization. So that is an example where we are trying to optimize the application. Here we are trying to optimize the network. And again, we are using telemetry from the network to observe and predict network KPIs. But here the control knob is inside the network, and it is a configuration in the base station, for example. And this is an example again from a live deployment where the operator has misconfigured how much bandwidth, how many carriers to allocate to the control channel on a particular LTE base station. And the system recognized that this particular base station was being underutilized and the bandwidth per user was pretty low, in spite of having a lot of spectrum available, because the users are getting bottlenecked on the control channel. And this happens a lot because operators just do not have the ability to configure each base station separately. They have one golden configuration that they use for the entire network because of complexity reasons. And with AI, you now have the ability to fine-tune configuration for each location in the network for different times in the day, rather than having to stick to a one-size-fits-all configuration throughout the network at all times that inevitably leads to poor performance for a subset of the network. Keeping on going to the last slide. I'll end with this vision. The vision, of course, is that we want to move to a world where the network is no longer a bit pipe, but the network actually is an active participant in delivering great application experiences on the network. So what we want to build is a layer in the network that provides real-time APIs to applications and allows applications or network slices, if you will, to dynamically request and receive programmable connectivity from the network. So as we get to these newer verticals that have demanding requirements, it will be impossible to deliver the kind of experience they need purely from best effort networks. Instead, we have to move to a world where there are APIs that allow these slices to dynamically kind of program the network, but you need an AI-enabled control plane in the middle to figure out how to translate application layer requests into low-level control decisions inside the network and deliver the kind of connectivity these applications need. And that's why I believe real-time AI is going to be critical. It's not enough to do big data analysis and the batch. It's definitely needed, but ultimately the complexity is in real-time decision-making and in real-time resource allocation decisions in the network. And that's where you need to build a platform that allows you to kind of deliver this kind of intelligence dynamically at the scale of a big tier one network. With that, I'll stop and I'm happy to take questions.
Yeah, let me ask you a question and then we go to the open Q&A. Now, what is the role here? There's obviously a role for the mobile operators, but what about the enterprise and the application providers? What role do they play? Are you working with them as well to build the ecosystem to get everything function together?
I think it's a two-sided platform. So the role obviously the operators play is that they are the ones that are providing the infrastructure. They are the ones that are providing the connectivity. But I think they also hope to not just be a bit pipe infrastructure. They want to be a provider where they are providing differentiated services. And that's That's the role the operator could play. On the other hand, applications and enterprises, I think that's where this application shift is going to make them behave differently. Historically, it's been good enough. The network's been good enough for a variety of these applications, or we have solved it by over-investing in capacity. But as we get to applications that require control over the network, where software is controlling physical things in the real world, or require very, very interactive experiences like VR and AR, increasingly these applications will need an API from the network to be able to kind of program the connectivity they need. So we've been talking to, and we have deployed with a couple of such enterprises and applications, and they increasingly see the need for having such visibility and control into the network. I see the biggest traction in the automotive side, where the level 3 and level 4 autonomy coming. There is an increasing demand from the operators to give predictive visibility about coverage, throughput, and reliability from the network, so that the car can take proactive actions to deliver the right kind of autonomy to the driver.
Okay, Sachin, thank you so much. And I think we have a few minutes left for the Q&A. Kendra, what's there?
Okay, great. Yes. Let's start with a question for Tero. What type of AI methodologies are typically used in the context of mobile networks, reinforcement learning, neural networks, or something else? And how does the best method depend on what you are trying to optimize?
Yes, so I answered the maybe also verbally here. So we actually get a lot from vanilla multi-layer perceptors. So basically very basic and with supervised learning. So I think people have tendency to go to reinforcement learning immediately when they don't have suitable training data. But what I try to urge people to do is actually go and work on acquiring the data, making the pipelines to work, so that and also the whole data infrastructure and data strategy to work, so you get data that you can use for supervised learning. It helps in all kind of, even if you don't end up using machine learning, the fact that you have done this exercise helps you to do your operations better. So we do have a lot of time series problems. So people would think the recurrent neural networks or LSTMs, GRUs, would be useful. They are to some extent, but not so useful as we would like them to be. So this is the biggest area we would like to see improvements in algorithms design, are the ones that address time series, anomaly detection, and prediction.
Okay, great. And we have another question for you, Tero, about RRM. I'm trying to find it in the question box here. Yeah, can you share a concrete use case of applying AI to RRM optimization?
Yes, sorry. So we will reveal details on specific use cases on due course. So we currently not publicly advertising what we specifically are doing, and I think we have a bit of embarrassment of the riches there. So there are a lot of opportunities we can do, and you can already see quite a lot of literature, even from past 10 years, on some of these cases that we are revisiting and looking. So I think you will see more on specifics, but naturally some of these things are the ones that we don't want to publish on specific improvements that we internally do in our network that is not visible in any other way than the network works better.
Okay, great. Thanks. Let's see, we have maybe just one more question. I know we're going a little bit over. Is it reasonable to deploy neural networks at the edge?
Oh, yes.
One.
If you ask me.
So, yeah, okay.
there's someone else who wants to take this, but I really think the edge computing, I mean, meaning here edge cloud computing. So for edge for us. So also people might say that edge is the end device or the end terminal, but for us the cloud edge, it is something that we have to deploy the machine learning if we want it or not. That there's latency, real-time latency constraints by the speed of light and other things that just in some low latency cases we can't use centralized cloud. So we have a push from the centralized cloud towards the edge, and then also data locality and overall total energy consumption is pushing things from the end devices, battery operated devices. So the moment you have some data that is not local to that device and you want to infer something, it is most likely more beneficial to upload the data to edge service or server and make the inference there and then download the result, rather than trying to download some extra data and then do the inference in the edge device. So I think these things are pushing other things pushing from the centralized servers to the edge and from the edge devices to the edge cloud. And I think the only place these meet are in the edge cloud. So I really believe that that's something that's very strongly in favor of edge inference in the mobile networks infrastructure.
And I just want to add that all the work that the industry has been doing to start driving an intelligent virtualized network really enable this kind of AI analytics running, inference running on the edge. This is not to diminish the fact that cloud plays an important role in the AI and inference. What we are saying is that just like Tero said, and also a lot of things that we discussed, there are cases in the enterprise side, you really do have a latency requirement. You really need to make some real-time decision and a data locality issue that force you or really pushes you towards making that decision on the edge. And we believe that the network is marching towards enabling that.
Okay, great. Well, thank you. That's all the time we have for questions. I want to say thank you to Monica, Caroline, Tero, and Sachin for their presentations. And thank you to the audience members for joining us on this webinar. The full webinar and the slide deck will be available after the event at sensafiliconsulting.com. And all registrants will also receive an email when the new Senza Fili report becomes available in the coming weeks. So thank you again, and we look forward to seeing you at future events.